Hey everybody, here on the table I have the brand new Anker C2000 Gen 2. Now Anker previously launched the smaller C1000 Gen 2, that's a 1 kilowatt hour model. Well, this one is a larger 2 kilowatt hour model. And Anker lists a bunch of upgrades for this power station. Now Anker boldly claims that this has the best idle power consumption in its class at only 9 watts. We'll be testing that later in the video. They also state that this is one of the fastest charging power stations with both AC and DC input at the same time for up to 2600 watts charging, meaning this will charge in less than an hour with dual charging inputs. They've also upgraded the fans to be much quieter. In the past, other Anker power stations have made a bit of noise while trying to cool off. It's good to hear that they have upgraded the fans. We'll see how loud they are later in the video. And finally, this is much more compact and lightweight than the outgoing F2000. If you remember, that was kind of bulky and super heavy. Well, this power station only comes in at 41 pounds, about 19 kilograms, and you can see the size is much smaller. Now I want to go through some of the specifications on the C2000 Gen 2, starting with the inverter here. This is rated for 2400 watts continuous output, and it can surge over 4000 watts. And you'll notice here they've included a 30 amp RV port, which means you can easily connect this up to a transfer switch or to your RV or trailer. Now the USB ports are also upgraded. You have two 140 watt power delivery ports. Then you have a standard USB-C 15 watt port and a USB-A quick charge 12 watt port. Now as for the DC output, Anker has included a 12 volt cigarette port rated at 10 amps, so we'll see how much power we can get from that later in the video. Now as for charging options on the power station, you do have 1800 watts of AC input here. The power station does support UPS functionality. It's actually UL listed with a cutover less than 10 milliseconds. Now this port here is good for up to 800 watts of DC or solar input as well. Now the power station is also compatible with Anker expansion batteries. For example, you can connect up their 2 kilowatt hour expansion battery for a total of 4000 watt hours. You could also connect up the Anker F3000 expansion battery for a total capacity over 5000 watt hours. So it's good you have some flexibility using their expansion batteries, and I love how compact these expansion cables are. Now what about pricing on the power station? Well, today is the announcement date for the C2000 Gen 2. It actually officially launches on October 28th. So if you purchase it during the pre-sale event, you can pick this up for $749 or about 36 cents per watt hour. Now after October 28th, the price does go up slightly to $799, which is 39 cents per watt hour. But both of those prices are still very good for an Anker power station. So with the specifications and pricing out of the way, now it's to the fun part where we actually do extensive testing on the power station. So my goal here is to find out the actual performance, and then hopefully by the end of the video, you guys will have a good idea if you want to purchase the power station or not. Now to make it a little bit easier, because these are longer videos, I do have a bunch of chapters at the bottom. So we're going to start with the AC inverter testing first. Remember, it's rated for 2400 watts continuous and a bit of surge power too. So let's see how it actually performs. So in my first inverter test, I wanted to see if the power station could run the maximum advertised load for 15 minutes, which is 2400 watts. Now during this test, my oscilloscope was showing an excellent sine wave output, and I measured 122 volts at 60 hertz. Now after 10 minutes of running the maximum load, the cooling fans were at full speed. I measured only 44 decibels with my sound meter from 3 feet away, so these fans are super quiet. Near the end of the test, I used my thermal camera to confirm the power station temperatures. I saw a peak of 120 degrees Fahrenheit near the exhaust ports, so no signs of overheating. The C2000 passed this test and was able to run the full rated load for 15 minutes without shutting down. Now what about the maximum wattage the inverter allows you to pull before it overloads? I turned up the load from the previous test till it got up to a little over 3200 watts and the inverter shut off. So you do have a little bit of headroom before the inverter shuts off from being overloaded. So in the next test on the AC inverter, we'll be seeing how well the inverter handles surge loads or inductive loads. Now it's rated for 2400 watts continuous, but I have some surge loads here, so we're going to see if it can power them up. Now since this is a larger power station, I'm going to start with the 15 amp table saw. If it passes that, then we'll power up the table saw and the vacuum at the same time. So for this test, I have my Klein clamp meter set to inrush mode on the hot wire. It's plugged into the 30 amp output to get the best results, and I have the table saw connected up here. So let's go ahead and turn it on and see if it powers up. So So it powered up the table saw just fine. I see a total of 38.66 amps. Now since it passed that first test, now I'm going to connect up the 12 amp vacuum and the 15 amp table saw. Let's go ahead and power these on. Keep an eye on that screen right there. 3, 2, 1. Now it did power up the table saw and the vacuum. There was a slight hesitation and I could hear a little bit of voltage drop going on, but it looks like we pulled 43.13 amps and it did power up those loads just fine. Now for my next test on the AC inverter, I want to use this outlet tester to verify if these outlets have a floating ground or a bonded ground. So with the AC inverter enabled, you can see that it does have a floating ground. Let's make sure the 30 amp output is the same. Yes, we also have a floating ground here. Now I've just connected the AC charging cable, so whenever it's AC charging or in UPS mode, you can see it actually picks up ground from the charging source. Let's make sure that that is the same case on the 30 amp output. And yes, we have a grounded connection now. In the next test, I want to see how fast the UPS cutover time is for the C2000. It's advertised to be 10 milliseconds or less. I have my desktop workstation, monitor, and studio lights all connected into the AC inverter. The power station is charging from the wall, it's in UPS mode, and I also have my oscilloscope plugged into the inverter as well to measure the cutover time. What I'm going to do is disconnect this from the wall, it'll swap over to battery backup, and we'll see how long it takes. Let's go ahead and test the first UPS cutover, so I'll start the recording. Now on the screen, you'll see the measurement of the cutover time. So between these two cursors is where the power cut out, and that is a measurement of 7.2 milliseconds, so a bit faster than the advertised speed of 10 milliseconds. Now the computer is running after that first UPS test, so that's good. Let's do 2 more just to make sure. So second UPS test in 3, 2, 1. Third UPS test in 3, 2, 1. So just quick flicker of the lights, but the computer is still running after all those tests, so this definitely passed. Now how much usable capacity should you expect when running loads off the inverter? I discharged the power station with the resistive load until the battery died and measured 1760 watt hours of usable capacity. This result is 85.9% of the advertised capacity, which is right on par with our goal of 85%. Now I also completed an additional capacity test with Anker's expansion battery connected for a total of 4,096 watt hours. When the power station inverter shut off, I measured 3,710 watt hours, or about 90.5% of the rated capacity. So with an expansion battery connected, you do get a slight boost in efficiency and you can double your run times. Now how much power is used as the AC inverter is turned on for a long period of time? I started with the power station fully charged and left the inverter on for 12 hours. The state of charge had only dropped down to 95%, meaning the inverter used about 5% of the battery over 12 hours, or about 0.41% per hour. Now that's one of the most efficient results I've ever gotten during this test. Next, does the inverter produce any interference? I measured 1550 millivolts of EMI using my dirty electricity meter, which is about average for the power stations I test. Now is that EMI actually audible? Well, connecting my guitar amp up to the inverter, I didn't notice any buzzing or crackling. For my last AC inverter test, I wanted to see how long the power station could keep my basement refrigerator running during an outage. After 26 hours, the inverter finally shut off. That's an impressive runtime for a power station with just 2 kilowatt hours of capacity. Now quickly recapping the AC inverter test results, starting with the max load test of 2400 watts, it did handle it for 15 minutes without an issue. The sine wave output was really good, and even the voltage was at 122 volts. I was most impressed by the fan noise though, only being 44 decibels. So after running max load for 15 minutes, the fan noise was super quiet. So I love that. Now moving on to the surge test, it did handle the saw and the vacuum at the same time, so I don't think there's any issues with surge. Now when we did the capacity test, we got right on par, 85% of the rated capacity, that's my goal. And then I was actually really surprised with the idle power consumption numbers. So as this sat idle with the AC inverter turned on, it only used 5% of the battery, or about 0.4% per hour. So that is one of the best, if not the best. I'll have to look through all my records, but really, really good idle power consumption just as they state. Now, when it comes to the UPS was also very good at only 7.2 milliseconds. Okay, so in the next section of the video, we'll be testing the DC output on the C2000, which includes the 12-volt cigarette port and the USB ports. Now right here, I have my 1500 watt DC electronic load. I've connected it into the 12-volt socket. We are getting a regulated 13.38 volts output. Now the 12-volt socket is rated at 10 amps, so let's go ahead and turn on a 10 amp load. And there it goes. We are pulling 130 watts. Let's see if it will do 11 amps. Okay, we've stepped it up to 11 amps. We're seeing 137 watts on the screen. Let's see if it will do 12 amps. And with 12 amps, it shuts off with an E0014 error, meaning the DC output is overloaded. So you can go up to 137 watts on the 12-volt output. Now this power station has an impressive USB selection. You have two power delivery 140 watt ports, and then you have a 15 watt power delivery port, and then you have a standard USB-A quick charge port rated at 12 watts. Now these two together are limited to 20 watts total. Now connecting into the first 140 watt port, we are seeing power delivery 3.1 EPR. This is a full 140 watts. You can see we're charging the power bank at 136, and we have about 135 coming out of the power station. Now when connecting into the second 140 watt port, we are seeing a slightly different protocol. It's power delivery 3.0 at 140 watts. We are seeing basically the same power. This is charging at 136, and we're seeing 136 going out of the power station. Now connecting to the third USB-C power delivery port, we're seeing dedicated charging protocol at 1.5 amps. We are charging this power bank at 9.4 watts. You can see 10 watts coming out of the power station. Now finally connecting to the USB-A port, we are seeing the same dedicated charging protocol at 1.5 amps, 9.4 watts into the power bank, and 10 watts coming out of the power station. Now I also wanted to make sure that you could use all four USB ports at the same time. So to test that out, I have both of the 140 watt connections to the Anker C300, and I'm charging my cell phone and a portable battery pack. Now you can see that the Anker C300 is charging at 265 watts with both of these connected for charging input. And if we look at the actual power station screen, you can see 293 watts going out through all four USB ports. So yes, you can use all four at the same time. Now what about using the 12-volt output and all the USB ports at the same time? Now if we take a closer look at the screen, you can see a breakdown of 422 watts. And what's really cool is if you go to this page, you can see a breakdown of all the power. So yes, you can use all the USB ports and the 12-volt socket at the same time. Now moving on to the next DC test, how much usable capacity can we expect from the DC output? Using my electronic load to discharge the power station, I measured a total of 1,875 watt hours as it turned off. These results were 91.5% of the advertised capacity, which is above my goal of 85%. Now, how much idle background power is used if you leave the DC output turned on? I started with the power station fully charged, and checking in 12 hours later, it was still at 100% state of charge, so the DC output uses very little power when enabled. Now let's quickly recap the DC output test results, starting with the USB ports here. I love that they have the two 140 watt power delivery ports, and I feel like having 4 ports is a good balance. Like some people might want more than that, but personally, I don't think I'd ever go over 4 ports. Now, as for the 12-volt output, you do have just this 12-volt cigarette port rated for 137 watts. It's good that they still included that because we have power station companies just removing the 12-volt output completely. But you guys know me, I love the high DC output, and for a device this size, a 30 amp output would be perfect for camping or overlanding or a van life scenario. So I was really excited when the Anker F2000 had the 12-volt 30 amp output, and I was hoping that they would have included on this, but they didn't. So you just have the 12-volt cigarette port. So guys, if you want to see a 30 amp output on a future Anker model that's in the 2 kilowatt hour series, let them know down in the comment section. So in the next section of the video, we'll be doing a bunch of charging tests on this C2000. Now Anker includes 2 different charging cables in the box. The first one is an AC charging cable, so you plug this into an outlet or any other AC charging source. And then the second charging cable is a car charging cable. It has a 12-volt cigarette port here, and then the XT60 plugs into the power station. Now I've rotated the power station so you guys can see the charging ports. Right here you have your AC input. This is good for 120 volts up to 15 amps, or a peak of 1800 watts. Now over here you have the DC input. This is an MPPT solar charge controller, good for 800 watts peak. Now this is the first time I've seen Anker use an XT60i connector, and below that you'll see two different voltage ranges. The top one is 11 to 28 volts. You'll see it limits the amperage to 8.2 amps. And then as you step up the voltage to a higher level, 28 to 60 volts, you get the full 17 amps input, and that's where you'll see the peak of 800 watts. Now first, I want to do some AC charging tests on the C2000. In the Smart app, you have full adjustability on the charging speed. So here within the Smart app, you can go into the settings, and then you have the AC recharging power setting at the top. Now you notice it's set to 600 watts right now. Anything under 600 watts is going to be silent recharging, so you won't hear the fans at all. You can go all the way down to 200 watts, save it, and then you'll see that the charging speed adjusts on the actual power station. It just takes a couple seconds. Now let's say we want to go up to maybe 1200 watts. Let's just save that and make sure it goes up to 1200 watts. Now as you jump up the charging speed, the cooling fans will kick on, at least after a little bit of time. I've noticed that the charging fans are really quiet on the power station anyway. Now let's crank it all the way up to 1800 watts, see if we can get the full charging input. I absolutely love power stations that have adjustable charging. So if you have like an inverter that's limited to a certain amount of power, or say you want to just slowly trickle charge it to put less stress on the batteries, you can do that. So if you look right here at the screen, you can see that we are charging right under 1800 watts. So this does have full adjustable AC charging, and it seems to work well. Now let's go ahead and move forward with the DC charging tests on the power station. I want to quickly break down the difference between XT60i and XT60 and how it works on the power station. So if you remember, the DC charging port is an orange style XT60i connector. There's a metal pin right here that communicates to the power station. Basically, whenever you use an XT60i connector like this that's active, you can get the full amperage input no matter what the input voltage is. So you can get the full amperage at 12 volts or at 60 volts. Now, if you use a normal XT60 connector, you will be limited to the voltage tolerances on the side of the power station. So if you are charging at a lower voltage, you'll be limited to 8 amps. And if you charge at a higher voltage, you'll be able to get the full 17 amps input. So that's the difference between using an XT60 and an XT60i. Now I've powered up my 1200 watt adjustable power supply to start testing. Now we are using the XT60 connector first just to demonstrate what happens here. So I have this set to 13.5 volts and 20 amps to simulate a car battery. But you can see that because we're using the XT60, we are only getting 8.12 amps input. So if you look here at the power station screen, we are charging at 111 watts input. Now, if the power station was fully empty, this would take about 20 hours to charge the power station. So it'll take a long time to charge when you are using a car charging cable. Now for the next test, I've swapped out the XT60 connector and I'm using the XT60i connector. And you'll see right away that we've jumped up in amperage. So we are getting almost 17 amps input and we're still charging at 13.5 volts. So if you want to charge quickly from a 12 volt battery, you can use an XT60i connector. You just want to make sure that you're using the proper wire gauge. So 12 gauge wire at least with a 20 amp fuse. And you can see we have doubled the charging speed. We're charging at 219 watts versus 111 watts. So now the charging speed is going to be around 10 hours to completely charge the power station if it was completely empty. Now I've adjusted the voltage to 18.5 volts to simulate 12 volt solar panels. So if you wanted to connect multiple 12 volt solar panels in parallel on the power station, remember you're going to be limited to 17 amps. So the peak input with 12 volt solar panels is going to be right around 300 watts. Now what if you wanted to charge from a 24 volt battery? I've upped the voltage to 26.2 volts. We're still seeing it right under 17 amps input, and now we've jumped up in voltage to 434 watts. So you do get quite an increase in power charging from a 24 volt battery versus a 12 volt battery. Now I've just upped the voltage to 40 volts to simulate larger format solar panels. So if you wanted to plug in two 400 watt solar panels or maybe two 450 watt solar panels, just remember you're going to be limited to 17 amps. So you can over panel the power station, but you'll only see about 17 amps input. So with 40 volts and 17 amps, you're going to get around 670 watts input. So basically the higher the voltage, the closer you're going to get to the 800 watts input. Now, what about connecting up a 48 volt battery to the solar charging port? I've adjusted the voltage of my power supply to 54.2 volts, and we are seeing a little bit under 14.7 amps. And we are maxing out the charging input on the power station. So we're seeing right around 799 watts. Remember, this is limited to 800 watts input. So one of the easiest ways to max out the charge controller is by connecting up a 48 volt battery. And a lot of people do this to kind of use it as a DIY expansion battery. Now in the next test, I want to see if the power station allows dual charging. So DC and AC charging sources connected at the same time. Now, if we zoom in on the screen here, you can see that we're almost charging at 2600 watts. And if we break this down, you can see that it's almost 1800 watts of AC input and 800 watts of solar input. So yes, the power station does allow dual charging. Now moving on to the next test, what about pass-through charging? Or the ability to charge the power station with AC input while having the AC inverter enabled, the USB ports enabled, and the 12 volt socket enabled. Now, if we look closer at the screen here, you can see 1760 watts going in from AC charging and about 467 watts going out to these loads. And if you push this here, you can see we are AC charging. And then you get a breakdown of what's happening here. So 5 watts going out to the 12 volt socket, 3 watts out to the USB port, and 500 watts going out to the other loads. So yes, pass-through charging does work on the C2000. Now, it's rated for up to 1800 watts, but what happens if we go over 1800 watts? Is it going to turn off the AC inverter? Is it going to stop charging? Or is the whole power station going to air out and shut down? I have this 1500 watt heater here, so let me go ahead and turn it on, and we'll see what happens to all the outputs. So I'm just going to turn this on max, 2000 watts, 2200 watts, 2300 watts. Okay, everything's still going here. We're actually still charging and the inverter's still running. So if you look closer at the screen here, you can see that we are charging the power station at 1916 watts and we have a load of 1865 watts and it did overload. Okay, so it allowed it for a bit of time. Let's see. The DC output and USB ports are still enabled, but the AC inverter did shut off and the AC charging shut off. Just be aware, if you pull over 1800 watts for a significant amount of time, it will shut off charging and the AC inverter, so you'll want to stay under 1800 watts. Now, after a couple minutes here, AC charging automatically resumed, but the AC inverter did not turn back on. So when you overload it, the AC inverter stays off. Now, what I'm guessing here is you could turn on the AC inverter via the smart app, but you'd want to make sure that your loads don't go over 1800 watts or it would shut off again. I also wanted to test the AC charging efficiency, or how much energy it takes to fully charge the battery. Starting from empty, I tracked the usage with an inline watt meter, and I measured 2440 watt hours to completely charge the 2048 watt hour battery, which means the charger is about 83.9% efficient. Okay, so let's go ahead and do solar testing on the Anker C2000 Gen 2. Now, if you remember, the solar charge controller is good for 800 watts. And so right here, I have 800 watts of solar panels lined up to use. Now, I've showed you guys these solar panels in previous videos. These are perfect for power stations with 60 volt charge controllers, because when you wire 2 of them together in series, they give you really close to 60 volts, allowing you to max out the charge controller. So what I've done here is I have these 2 wired together in series, I have those 2 wired together in series, and then I've wired them together in parallel to make one 800 watt solar array. This is a 2S 2P solar array. Now, the wiring on these Calson 200 watt solar panels is super simple. I basically have 1 wire coming from each of these solar arrays. So there are 2 wires going in, and I have combined them in parallel going into the shed to charge the power station. Now, I've just plugged the solar panels into the power station, so let's check the screen to see how fast we're charging. So right underneath the state of charge, we have the power input, 792 watts. So just shy of the 800 watt limit. Now, I was looking at the numbers. Basically, this is a limitation of the Anker power station. It's limited to 17 amps. Now, if we were able to get 18 amps into the power station, we would be able to hit 800 watts. So we're just barely shy of that because of the 17 amp input limit, because these solar panels put out a little bit more than 18 amps. Now I also tested having solar panels connected overnight on the C2000. In the morning, once the sun started coming up, the power station started charging, and I didn't notice any issues during this test, so it's definitely okay to have solar panels connected all the time. Now I also tested having the power station completely turned off and then connecting solar input. The power station turned on and started charging, so solar panels do wake up the power station if it's died or if it's been turned off. So after completing all the charging tests on the power station, I love that this supports dual charging with up to 2600 watts input, so it charges super fast. Now there's just one little complaint that I have, it's really minor. I would say the 800 watt charge controller is the smallest that I would allow for a power station this size. I'm just a little bit bummed that the previous F2000 had a 1000 watt charge controller with a 20 amp input limit, and this one here has a 800 watt charge controller with a 17 amp input limit. So they kind of downgraded the solar charge controller versus the previous 2000 watt hour power station. So I'd love to see it maybe around 1200 watts, because then it would allow you to charge both the battery and the expansion batteries connected in a decent amount of time. Now let's go ahead and take a second to go through the Anker Smart app. I've noticed a few new features here. Now starting at the top, you have the power station with the state of charge and the internal battery temperature. Now on this home screen, you can see the inputs and you can see the outputs, and you have the ability to toggle on and off the car output and the AC output and the screen. Now I've noticed this mode button underneath the power station. This is new for this power station size. Now there are 2 energy management modes, and then there are 2 backup modes. Now standard mode is basically what you've seen here in the video, all the testing that I've done. And then you have time of use mode that actually allows you to enter in the electrical price throughout the day, and then the power station will automatically charge at the lowest price levels. Now below that you have Storm Guard, which allows you to have this connected to Wi-Fi and grid power all the time, and then if you have a storm alert in the area, it will automatically charge the power station of 100% state of charge. Now the fast charging plan basically allows the power station to charge as fast as possible anytime that you have DC and AC input. Now there are just a few other settings that I want to cover. I already talked about the AC charging adjustability, 200 watts to 1800 watts. Now below that you have the car charging output power saving mode. This is an eco mode for the 12 volt socket. And then you have the smart AC output mode. This is an eco mode for the AC inverter. You have device timeout settings. You can change the language, screen brightness, timeout for the screen, and screensaver. And I like that you also can set charging and discharging limits. I have it set to 1% to 100%, and you can go in here and just adjust it how far you want it to discharge and charge every cycle. Now below this is the most important feature that I've seen on this power station. This is called output port memory switch. Basically, if you're using the power station and it goes all the way down to 0% and turns off, once it starts charging back up, it will automatically enable whatever ports you had enabled. So if you had the DC output on or the AC inverter on, it would turn those back on once it hits 10% state of charge. So that is super cool. I would definitely recommend having this setting enabled. Now moving down, you can change the device name, you have Wi-Fi settings, you can change the temperature, you can see the serial number, and you have help and feedback through their customer support. And of course, you have the ability to update the firmware. So with all the testing completed, I can now put this through my power station grading system. Now up on the screen, you'll see the results for the C2000 Gen 2. It actually missed out on one item, so very, very good performance here. It lacked having 150 watts of DC output. So if you really need that, you're gonna wanna look for a different option, but otherwise this performs really well. It got an A grade, or 9.5 points out of 10 points available. Okay, so we're coming to the end of the video here. We've done a ton of different tests on the power station, and now I just want to keep things simple and do a pros and cons list. So I've kind of put some things together. Let's talk about the pros first. The first thing was the idle power consumption. Now they advertised this to have 9 watts of idle power consumption. This had the lowest power consumption, or AC idle power consumption, that I've tested with any other power stations. So super efficient as it sits idle. The next thing was how compact and lightweight this is. This is like a third less the size than the previous F2000. That thing was so big it needed wheels and a handle. And this is so lightweight and small, only 41 pounds. So I love that it's so much lighter weight. The next thing that I put down were the quiet fans. Now, when this is running a 2400 watt load, maxing out the inverter for 15 minutes, 44 decibels. That is very, very impressive. It also has a super fast UPS mode at 7.2 milliseconds. The UPS is actually UL listed. And remember, in the Smart app, you want to enable that output port memory switch so that when you're using it as a UPS and it dies, it'll turn the AC inverter on automatically once it starts charging. That is a really cool feature, but you need to turn it on. And finally, the amazing price. The fact that Anker is launching this at 36 cents per watt hour is absolutely amazing. I have not seen an Anker power station with that sort of price. You know, you have their reliability, you have their 5-year warranty, you have their customer support. So 36 cents per watt hour is what you'd see from a budget power station. And this is not a budget power station. Now let's go ahead and talk about the cons. Now, I already mentioned these two. Basically, the lower sized charge controller, 800 watts. I would have loved to see a larger charge controller on this. And the fact that this has a lower powered DC output. So 137 watts from the 12-volt socket, but I would have loved to see, you know, a higher DC output. That's what everyone's asking for. So, you know, this is doable. You can run a 12-volt fridge off this just fine, but when it comes to running multiple loads or diesel heaters, you're going to need more wattage than this. Now, after seeing all the testing completed on the C2000 Gen 2, you guys will have to let me know what your feedback is about the power station. Make sure you leave a comment down below. And for anybody that's interested in purchasing this, I will have a link in the video description to their early bird sale price. Remember, this is on sale for $749 if you purchase it before October 28th, and after that, the price will go up. Now, a special thanks to Anker for sending out the power station for this video so I could test it and you guys could see how it performed. And as always, a special thanks to you guys for supporting the channel. Now, until next time, we'll see you guys later.